Hello everyone, this is called panel with three amigos because we are doing this in the backstage, and these two of people are very good friend of mine. I look a little bit younger, but I'm the oldest one, of course. It's Goran. So basically, we have very interesting thing like today. Basically, you can switch. Maybe see me that I switch from one studio to the other, but basically the studio switch from one stream to another. That's the true form. So basically. Today, we are going to talk about learning data science through formal and informal education. We all the time talk about, okay, how we can start a career, how we can excel in our career, how we can become better. And this is something that most of the time you can see somebody only presenting their program, or they can present, I don't know, their workshop, something like that. But I think that sometimes we need to go back to the basics. What does it mean? Talk about what this because I really do not believe that approach that everything fits for everyone, that you can fit everyone in one shoes. That's not true. So basically, I think in the end, every person needs to choose by themselves. So basically, today with us, we have two good friends for the conference and a good friend of mine. First one is B.Urosevic&G.Milovanovic, who basically is the owner and owner of Data Collective, the company who is organizing tons of excellent workshops. Sometimes they are related to art, sometimes they're related to more to data science to create skills for data science. And the second panelist is going to be Professor B.Urosevic. Thank you, Branko, who is basically the let's say founding father, I can say, about of the interdisciplinary programs in Serbia, and basically he created Master in Computational Finance, which is something totally like on the next steps. But like I said before, we maybe start. I would just like maybe 1 or 2 sentences just to explain to your both of your problem, just to explain to the people your background. I think that you'll do much more passionately than I'm going to do.
Well, it was okay. I can start to Branko, perhaps.
Well, so first of all, it's a great pleasure to be here, to have a chance to talk to Alexander and to Goran, both very good friends of mine. And so first of all, I'm come from the physics background originally. My father was a physicist, and then I was a physicist. But then, the market forces kind of made me think I would even have a PhD in theoretical physics, and then market forces kind of pushed me to look at other careers. I ended up in business, first in consulting and then in finance. And I was doing finance for the past 25 years at least. And so obviously this is how one thing led to another, and I wanted to do stuff in Serbia, so I could have stayed in the US, got my PhD. And I came back and developed first a program called IMQF, which was basically at the Faculty of Economics in Belgrade, at the University of Belgrade, and which was a very successful program, but it did not have enough data science component and certainly did not have the programming part. And then from about 3 years ago, I went to Računarski fakultet, or School of Computation at the Union University in Belgrade, where we created a completely new type of program combining finance with computer science, with data science, machine learning, and even blockchain developments and fintech.
Oh, Goran, maybe you can just as an intro for yourself.
Well, similarly, I studied mathematics, philosophy, and psychology at University of Belgrade. Later on, I did begin my PhD studies in cognition perception at TNU in the United States. So it's been 20 years of an academic career, as you know, as well as in Branko's case. In academy, you get to teach people a lot, you need to tutor people. So I started very early as 1993, as a TA in psychology, where I taught experimental methodology mainly for cognitive sciences and general psychology and similar. Then I taught at the university during my PhD studies for 2 or 3 years, mainly cognition and cognition-related subjects. All along the way, I was working as a private consultant and tutor in statistics, statistical analysis, methodology, etc. And since 2017, I started Data Collective and started providing professional training services. In the meantime, I spent 3 or 4 years working with an American-based edu startup in their introductory data science courses and mentoring people around the world in that science.
This sounds like I said, I know that your background, both of your backgrounds are impressive, and basically you're the ones like me. I think that your basically path is the pure form of data science, because you go to one direction, after that you go to the second, third one, but all the time you stay on the direction. Like, because you can see it's somebody see chaos, you both of you saw, okay, there is a line in that chaos. Basically, we are going forward, and we are basically staying happy with what we are doing. And maybe not all of the people understand, but we understand deep inside of us where we are going. So basically, my question to you, Branko, is because you said you have created the Master in Computational Finance, which I think that this year, correct me if I'm wrong, we have more than 40 enrolls.
That's right, 48.
48,
Yes.
so it goes up like I think 2 or 3 from the last time we spoke. So basically, what is the role? What role does data science play in this program?
Well, it's crucial role because finance is data driven, and it's most literally so, because people, when they make financial decisions, they're starting with the prices. Prices are ubiquitous; they are available for free to look for all kinds of things. Of course, there are some prices you need to pay for, but basically there are lots and lots and lots of data. It's one of the most data-intensive industries that you can think of. And so the result is we need to kind of have a formal introduction to that, since we accept people from different backgrounds. So they come sometimes without knowledge, not only of data science, but perhaps without knowledge of programming, with some minimal knowledge of mathematics. Sometimes they come with a lot of knowledge of programming, sometimes they come with a lot of knowledge of data science, sometimes they have with zero knowledge of finance. And so you have to do this background improvement at the beginning, the way to make sure that everybody is on the same playing field through the bootcamp. In a bootcamp, they study Python and R, introduction, using the examples of finance as a kind of motivation, so that those who are actually good programmers can still find value in connecting what they know with the topic of finance. And then there are 2 semesters of intense coursework, which basically is again centered around working with data. 2 of the key courses in that respect are statistics and financial data analysis, where not only do they learn about the various cross-sectional and time series models, but they also focus on understanding the difference, which is oftentimes misused, the difference between correlations and causality. And this is something that is quite important and oftentimes not understood. There are lots of mistakes can be made. And the second one is after they learn enough statistics, then we go into the machine learning in the second semester.
Yeah, I totally agree. There's one sentence my first boss ever told me, and this is that it's very hard to translate on English, but on let's say the like meaning is the correlation does not mean causality. It does either way. So basically, it's one of the most important fundamentals in doing data science, basically. So basically, when you're talking about data science, and this is more, let's say, one of the things like informal education saying this kind of word and sentence to everyone listening is, my question for you, Goran, is what are the key challenges that you try to overcome when educating data science?
All the key challenges are essentially related to the characteristics of each individual student, each individual learner that enters the course, right? So, the way I like to think about it is, of course, from experience. I'm talking about the experience with people I already met and had a chance to work with them and educate them, provide training to them. So, for example, imagine that you work with someone who is already a software developer, a software engineer, and who presumably has some formal background, some education, right? The chances are that they already have all the necessary pieces because the formal background, the formal education provided probably enough and more than enough of mathematics that you need to, lay the basis for data science and machine learning. So with them, it's one approach, right? So those people, they only need to, essentially, if they want to be qualified to do data science, they essentially need to play with the same pieces that they already have somewhere in their memories, in their past experiences, in their education, just to learn how to recompose them in a data science project, to use that knowledge in a different way, right? So that's what I say. So what's teaching data science is putting probability to work. Of course, it's, to put that thing at your disposal to make it work for you, not only, leave it on the blackboard. Then again, it's a completely different case. If you're educating people who have a background in some empirical science, and that's often the case, I still think that's probably the most, the best background for a data scientist is essentially not in engineering, in my opinion, okay? I think the best background comes from empirical sciences, and then you face different challenge, and that is they typically know only some basics of computer programming, and they have only some very basic understanding of computer science. Okay, so that's the fact that that's the place where you have to work with them and invest your time into that. So they actually learn how to express the logic of the scientific method that they already know and understand, how to phrase that not in natural languages and scientific papers, but how to phrase that in programming languages. Typically, scientists find that game quite amusing and start playing around with things very quickly. Say the third group, for example, that I meet very often, most probably because I have a social science background, computational social science background. Social scientists, right? Typically, they don't get that level of education in mathematical statistics, even if they were working in serious empirical part of social sciences, so not what we call humanities, but real social sciences, where you learn methodology and statistics. But typically that level is nowhere close to the level that is obtained by studying physics or engineering or something like that. So in such situations, you need to focus on teaching probability theory, numerical simulations, and things like that to get them, learn how to work with these things and come to the level which is necessary for data science. But it really depends upon the person, So you have to understand who are you working with, and you need to understand the goals and motivations. That is really very important to help them put all that education in a context. If it goes out of context, it looks like boring things, those subjects at university you never wanted to see, right? If you go that way. But if you're able to put that into context so that they understand it and give meaning to it, then you're somewhere close to the road to the success, right?
Yeah, basically, like two sentences from you, what you just said. First one is that we have two physicists here sitting, if nothing else, and one somebody who studied sociology, like that's one of the things. The second thing, my good friend of mine, B.Urosevic&G.Milovanovic, who is like head of AI at the Game Turner and Algebra AI, he said that he thinks that data science basically missed a chance, and still not agree, but that it's still missing a chance, but to basically put inside of the company scientific approach. Very interesting sentence, to be honest. And I think this is very interesting. And when we are talking about scientific approach, one of the problems that we are trying to solve all the time is optimization in terms of being very efficient. Because being efficient is not only about saving some time, but also some of the system can work much more naturally if they are optimized in the end. So my question to you, Branko, is very simple. Modern financial organization basically lack huge amounts of data. What are some of the challenges related to efficient use of data in this organization? Is it only about the people working inside of it, their lack of knowledge, or it's much more?
So first of all, financial organizations have collected data for basically as long as they existed. And yet the recognition of the importance of data was not equal until maybe the past several years and big crashes on the market when the risk management, for example, was created and then supported to become an important part of any financial institution. And so basically, if you look at which are the places where people know the most about working with data, that would be risk management, for example, in Serbia.
Okay, yes, I can.
There could be also people that work with client retention or CRM to some extent, and then there could be some other groups. But the problem is several-fold. First of all, on the top level, the CEOs and executives, they understand the importance. Everybody is kind of clear that there is an importance to use the data efficiently, but they're not sure how they go about doing that. Secondly, the organization is such that there is already legacy systems that are totally disconnected from each other. So you have a collection of things in various spreadsheets a lot. Then when the regulators or the owners from, depending if you are let's say Raiffeisen or somebody, I'm making it up, maybe it's not Raiffeisen, but basically they would collect from some Excels, as it becomes needed. But let's say that the executives need to make decisions based on data. It's very hard to do it like this, unless you have an integrated data management system where basically people can play what if analysis easily, what if you do this, what if you do that. They are hard pressed to make data-driven decisions. And so a friend of mine who is a very experienced person working in many banks as CTO, he told me that basically not more than 25% of the times in the most advanced in Serbia bank in that sense are decisions made based on data. And the rest of the time they're made on best guesses, gut feelings, and so on. And this is in the best bank in that sense. Where people are having systems.
It's easy. You simply in that situation, in that context, if everything is simply dissolved in hundreds or tens of Excel spreadsheets, you can easily simply give up making data-driven decision making.
So
proceed by horoscopes.
There is another issue, namely, of course, there is an IT department in every bank, but the people in the IT, they are in a world of their own. So basically, they can sit there, they don't really care to learn much about the business, and they want to keep and guard the kind of monopoly position that they have, so that nobody understands what they are doing, and they don't understand what other people are doing. And so it's kind of conversation of the deaf people.
Job security.
The guys who know with computers.
Correct. And so, and then if some big boss says, well, I need such and such, then they say, this is the field such and such, from whatever the appropriate data is. So it's very hard in a setup like that, even when all the executives are highly interested in having something to work. It's not an easy thing. So it's a task to be done, and there are definitely people interested in helping companies also do that.
Basically, have also to first of all, one person told me that what is legacy? Legacy is basically the issues are one of senior leaders say, "I told you so." And the second one is task. The most important task with IT, manage to survive a day with IT person, especially DevOps. That's hard, but. Basically, I would like to maybe if both of you can share a little bit about this next question thing. We are coming back to the roots of this panel, and that's we are witnessing a proliferation of modes of teaching and learning opportunities for many fields, including data science. What, in your opinion, of course, makes formal education still very important in this field?
Well, it can be the value of good formal education, academic good formal education, it can be understated and underestimated. It's your time spent in an academic program. That is the time where actually you have to, where you should, if you can, if a person can do that, right? Face the scientific and engineering problems at the level of their, deepest complexity, and learn about the connections of all things in the field where they're going to work. Learn about the principles, right? Even if in practice, which is more often the case than not, they realize that some of the principles they learn in formal education cannot always hold. Many times you need to improvise, you need to solve problems in an environment where you actually have to perform constraint optimization, because you simply cannot do all the things that you can do in theory and on the blackboard, but that doesn't make the academic programs less work. So I will be open in my case, right? So what I did during my academic, my formal education, that is what actually made me into a data scientist, right? So I simply switched from doing exactly what I was doing back in school. I started doing that from the market, okay? Of course, I had to learn to adapt, right? So that, simply getting to be that flexible in order to work in a more dynamic environment than academic one, because actually the real market is not as comfortable as your academic environment, right? It took me years, of course. That is what we call experience, professional experience. But then again, when I will go back and say, the most important things that you've done in your life, you've done that in your academic base, right? That's the basis, and that's the grounding. So that's the time that people should learn to, experiment, express themselves creatively, figure out what are the opportunities, to develop a vision of the world through the lenses of their profession, what they're learning to do, right? So it's absolutely the role is precious. The problem is that not always in the academic environment is something like that possible. So many people will say, with the contemporary organization of the work in the academic environment, look, seasoned researchers in academia don't find enough time for research that they need to do because they're overwhelmed with lecturing. It's one of the huge problems in contemporary academia globally, not only here in the United States, globally that's a problem. And then students have the tons of workload and homework to do, etc. So it's difficult to focus on something, but whoever can walk that path and work like a real scientist and engineer with a vision on some problem, okay, that somehow reflects in the practice of this world, that's simply an irreplaceable experience, I would say.
Okay.
Well, you put everything so nicely, it's hard to improve upon this. I'm just going to say my experience is kind of the same. I studied very hard subject of theoretical physics, where I had to learn the methods of thinking clearly about different and not very easy to grasp concepts such as algebraic topology, and cohomologies and all that. And not that I use them now, but it somehow allowed me to believe that I can learn anything. If I can learn that, I can learn anything. And maybe that knowledge is actually important, that you do something challenging. But on the other hand, there is sometimes a danger that you can have like something very challenging, but totally devoid from anything that you can relate to. And so after a while, I got tired with that because, even though I was able to manipulate all these maths and formulas, I wanted more practical applications. So I ended up in finance. There I could very clearly see what is the objective, which is to make a lot of money. It's easy to get the intuition for what the goal is.
And we're essentially use derivatives, not cohomologies.
Exactly. Yes. So, but basically, you have put it nail on the head. So when, if you think about it, connecting different subjects, and this is sometimes some schools are better than others, connecting different subjects within a particular course and even outside of this, putting all the courses together to see how, as a whole, we can look at the world. And so that's.
But it's also, I think, the very challenge of serious academic studies, especially when we are talking about the graduate school. That's also the thing. As you put it, just survive, do it, because after that, it seems way easier. That's true.
Like somebody smart says, it's not about that, it's about proving that E equals MC squared. If you go into not totally likely to go quantum mechanics, oh my god, I don't want to. Okay, Branko, I would like to put you on the spotlight here because you're not only the head of mass computation finance, you're also vice dean of the School of Computing in Belgrade.
No, I'm vice rector of the University Union. So
yeah, sorry for that. Yeah. But my question to you is,
I will take the title from rightful owner.
Basically, I would like to ask you, what are the drawbacks of formal education?
Well, okay, so basically, to get a good formal education experience, you kind of need to avoid two pitfalls. So one is you can make things overly abstract. So basically, only people who are genius in abstract thinking can follow, and the rest of them are kind of roadkill along the academic road. And that happens. And I have seen it happen. So I'll give you an example. So there was a course at Berkeley where basically the guy was teaching, assuming that everybody would know how to learn how to work with data, and the course was about econometrics. So econometrics is application of statistics in economics. And so basically, people did tremendous amount of theoretical work and not a single data application. And so most of them were kind of puzzled. So what do you do with that exactly? And so the whole course, they got good grades and they had no clue. So that's one pitfall. The other pitfall, and he said, well, this is what I do. I don't care whether this is useful or not. He actually said that. So, okay, so another pitfall is you can hear people who say, but I'm focused on practice. And by doing that, you do nothing rigorous. There is no rigorous thinking. So there is no connecting of anything deeper, understanding of concepts, but they are clicking on the buttons, and you say, I'm doing machine learning by clicking here. And if you click there, it gives you something. You don't know why it happens, whether you should trust it or whatever. And so you need to avoid these two extremes and come up with something in between. And how do you do it the best way? We all learn. We try to learn and improve as we do it. Obviously, both of us put a lot of effort to try to kind of develop ourselves and people we work with to kind of help with that. And then, what are the other issues? The other problem is that formal education is very rigid. At least when it comes to Serbia, the way things are set up with the accreditation process and so on, you get 7-year accreditation. You can change a little bit the program, but you cannot do it too much. So what does that mean? 7 years is a very long period. Imagine the field like data science. Maybe the whole field disappears and becomes to be called something else.
Yeah.
You know, or
No, don't say that. Don't say that.
no.
Yeah.
So it's something, you know, things change a lot very fast.
That's true.
And so you kind of put the nails in the programs and say, now, from now on for 7 years, more or less, we need to stick with that. Secondly, when you try to look for good teachers, you can look for good teachers, but you need to have 70% of them to be full-time employed by your institution. Now, in a country like Serbia, where there is a small number of people, which is even smaller by the day, we have lots of smart people live abroad. And we have not too many foreign teachers can come and teach or want to teach. Then it's a problem, because then, you know, who is going to do all these teaching? So there is a proliferation of programs. Everybody wants to have something related to data science. Everybody wants to have, in every economics department in the state schools, you have now business informatics. Whether or not anybody there knows
Business
much about
informatics,
that.
information management, different things.
All kinds of stuff, yes. And so, in fact, you can accredit it as a program in social sciences. So, even though they don't talk much about social science. So, the point is, there are lots of these weird things that happens in the process of how formal education is set up, which you do not need to face when you do your informal education, because you can design things which make sense.
Academia cannot be agile. That's a problem.
Yeah.
So that inertia, it's it is understandable, which unfortunately doesn't make things better. But that is true. You know, universities are conservative systems conservative in a sense of scientific conservatism, right? So a healthy form of conservatism. So you don't get to change things very quickly, right? Add bureaucracy in the whole process, and then add governance in the whole process, the accreditation processes and everything we talked about. So academia cannot, most probably will never be able to function in what we contemporaries say agile, right, approach. Unlike informal education where you can do these kinds of things. So I mean, maybe we wanted to talk a little bit about the same thing as a mirror question of what ups and downs of the informal education.
We can continue with that.
So here's the thing with informal education. So the upside of informal education is that one. We don't have to wait much, right? So we have
You can try different things.
Absolutely, we can try different things. The experimenting is not that expensive. Like, so if one training course fails, it's not the same as the department in which was invested. I don't know how much fails, right? That's a completely different scale. Also, a new thing happens in the market, new classes of algorithms, mathematical models are introduced. Someone figures out that, I don't know, the optimization XYZ can be speed up by orders of magnitude. In that way, we can start teaching that immediately. Of course, if you have people who follow the field and understand it, that's the reason why as I told you, I prefer to work with people who have a good academic background, right, in this field, right? Why? Because that guarantees me that they're able to follow the developments in the field, which is extremely important, right? So that's for example, most probably that's the upside of informal education. It's flexible. We can easily personalize it and adopt to each individual learner if we work in small groups. That may be the downside when you take a look from the business development perspective, right? It's very difficult to scale if you want to have real personalized and in-depth educational period, right? We'll talk about that when we come to the question of these MOOCs, right? Yeah. Which is a different perspective altogether when we take a look at the massive online courses, right? So that would be the upside. Now, what is difficult in informal education is managing people's expectations. That is difficult. So that's the situation that I face from time to time. You know, this year I taught a very intensive short summer school in machine learning in R. Okay, and I had one of my colleagues. He's a physicist, and you know, at some point I was explaining the very simple optimization of a simple linear regression model by the method of least squares. And following that class and the discussion, right? So he's very young, of course, he's just a young professional. He's entered the data engineering, data analytics. He told me, no, I remember from my academic studies that method of least squares that you mentioned.
Yeah,
That's very,
it's in the first year.
That's what he told.
Yes.
He told me it's in the first year.
No.
But I never saw the application so clearly before you showed me how I can use that thing to optimize statistical models, right? So that is maybe what the real role should be of informal education, at least at that type of time trying to pursue the data quality graph, the connection, right? So this is what you bring from school, right? And this is how you put it to work in the market. And the downside, as it started to explain, is managing people expectations. So for some reason, it seems that being a data scientist or a machine learning engineer is almost the easiest thing in the world these days, right? Yes, I mean, you simply, you take tons of courses, you listen to it, you learn Python, and Python is of course easy. We all know that Python is easy, despite the fact that it really takes a year to master the language properly, right? But people think everything there is easy, and now we have all these advanced tools and so many education, etc. You can do it very quickly, which is true, which is not true. And then that's something that I have to share with my students from time to time. If I'm able to explain to you how to use least squares or maximum likelihood estimation to optimize statistical models and enter the field of statistical learning, that's good. But if you have never heard in your life, ever before, about the likelihood function and what the least squares are and get into my course, I could have only as much time to explain to you to make up that knowledge for you. There's a reason why I always say, you can start without a good academic background. That's going to be difficult. And the best start is with a really good academic background.
Okay, I agree with you, but there is some danger in only filtering people with good academic background to get in, because first of all, not counting now all the big numbers of Russians coming with good academic background who are doing stuff, but if you're looking at our own population, we don't have huge numbers of kids anymore, and so we cannot, and in companies, for example, in banks and so on, they have a hard time attracting new people, because they are not so competitively paid. They don't even know how to write down the proper call for work, for the announcements for positions. So there are all kinds of issues, and so they need to reskill their own people. So you need to work with people that exist rather than only with the top people. Because with the top people, you don't need to do much. You point them out to stuff, and they're going to do it, and then soon they can teach you. But there are some other people that need some help, and then once they get help, then they can develop. So, for example, my experience is that lots of economists who decide to learn to program, oftentimes, and to work with data, oftentimes they get to be very good if that was their own decision that they really want to do it. I think the motivation is absolutely critical. So when I meet somebody in a program, I'm always having maybe 1 hour at least an interview about all kinds of things related to that person, trying to understand what they are as human beings, not anything technical, just understanding who they are and what motivates them and so on. Trying to figure out whether this is something they are doing just because some people told them that this is a good idea because they can easily get jobs, which is true. There is a huge demand. But on the other hand, if they are not doing it for the right reasons, i.e. they are not interested in actually learning this stuff, they are not going to be all that successful in the long run. They will get some jobs, but from there to actually keeping the job is going to be, or maybe doing very great stuff. This is different.
I would like to ask you one question. Like basically, we talk about Goran has talked a lot about his program as well. Like what he thinks in informal education as well. Basically, Goran is working with a smaller group of people in one place, and MOOC is working with a large bunch of people at the same time. We're going to have Josip Portillo from Udemy as a keynote at Friday at our conference. Basically, your program do the both. So maybe if you could tell us a little bit more about this kind of approach.
So it is kind of in between. Certainly nothing as big as MOOCs, no question. So what we are trying to do, in order to be able to scale it, I'm actually really pushing the idea of working in groups, and not just any group, but groups of actually diverse people. People that will show up in a workplace together. So, for example, an economist, and a mathematician, and some programmer, and so on, and maybe groups of 3 to 5 people. And so, why is that good? Because there is a lot of intergroup learning as they work on problems together. Yeah. And you also get used to how other people think, who are different from you. Because if you only have people, let's say physicists, and they get together. Of course, they can be probably quite successful in some things, but there is not as much learning as combining that with yourself. And so one of the things that I ask everybody when they enter, are you willing to work in a group? Are you willing to help with what you know? For example, if somebody is, so one of the participants in our this year program is somebody who worked in Google for 7 years, is a software engineer, very good one, and now he has his own blockchain firm in Bucharest. And so basically somebody like that obviously doesn't need to learn programming in Python, but what he has no clue about, he doesn't have any clue about finance. And or thinking about business in a more deeper way, so he knows something, but obviously he has met somebody in Google, but it's limited to the area where he was working on. And so therefore, so we can pair him with some good economists or some bankers and so on. And so this is not an easy task to find the good ways to do it, but this is how we can diversify the intake and also scale, because we have a relatively smaller number of groups. So let's say if you have 40 people, you have maybe 10 groups. And so basically we can go up to some number, but not too large number, because we want to have a personal relation with all the participants, and we need to know about their progress. And so this is, always a balancing game. So we need some minimal scale for this to work, because otherwise we cannot have diverse groups. On the other hand, if the number is too big, it becomes unruly and
not to scale with dismissing online courses, but the thing is always when people ask me, should I go for something like that? It's a very simple thing. I tell them, listen, you need to think thoroughly about your background. Why? If you enter an IT-scaled, massive online course, right? So the chances that the materials will be very high quality are really good. You have tons of free online materials to learn. Now imagine that somebody really pushes into it. So they produce good teaching, good learning materials. But the problem is that one really needs to consider their background for these massive online courses, because it is rarely a case that there will be someone really alive talking to you and being in discussion and communication with you between two screens full of mathematics and Python or programming, right? So good, but the question is for whom, right? Who is your background?
And when you talk about that, I would like to ask you, what do you think, how important is the main knowledge for data scientists?
I think it's of essential importance. Maybe perhaps I really am this time the right person to ask that, because I spent years doing the so-called generalist position in data science. And as well, I spent working as a data scientist for Wikidata and was running between the big data backends and even pushing dashboards to production and doing machine learning in between, and analytics for various use and research cases there. Generalist positions, first, they are very difficult. Second, they are rare. You do not get to observe too many generalist positions in the job market. So it is not a good assumption for any young professional who wants to start career in data science or machine learning that will be some Swiss-like generalist position, rare, risky, etc. So that makes the main expertise essential. I have people. I will give you a real example from my experience. Not once, many people ask me, listen, say, you're good data science. People think that you're a good data scientist. You have tons of experience. I'm probably almost 50. Yes, I have tons of experience. Okay. Why don't you go for financial engineering, for example? Right? And then I have to explain to them, listen, my whole background in the following 10 to 30 years, academic plus professional, I was doing distributional semantics, causal networks, decision making, and things like that. And that really doesn't overlap with financial engineering too much. I don't know much about time series analysis and signal processing. It's simply not my specialization in life. I did some other things, even back at my academic studies. Sometimes that background can be used as a generalist, but for a position like that with Wikidata, that's a huge gap. Okay, so I know about that, right? So people don't get to understand that thing seriously. Understanding the marketing which you're working on, what we say the domain expert, is completely essential for being good in what you do in data science.
Yeah, I think that this is important thing to say. For example, my background is from financial analysis. So basically, when I'm talking with somebody who has a financial background as Branko, it's much easier for me to talk about what is the. It's very, very easy to connect, because I have somehow I didn't even choose to be, but my two very, very long to do very long time. It was like inside of NCR and Cube, the financial banking data, very specific, basically, from different point of view, of course.
It's essential. It's essential. The management is essential.
And I think that this is perfect intro for my maybe last question from Branko is that you often talk about the importance of integrated education process. Could you tell us a little bit more about it?
Yes, so basically, I have to say, one of my key desires with this program that I'm creating and developing with my friends and colleagues, because this is a labor of love for all of us, I have to say. I mean, our teachers work in all kinds of countries in the top institutions. Usually they are practitioners who actually also have PhDs and so on. So why do we do what we do? And what we do is we try to connect, to teach, for example, people data science and programming by using finance as their motivation, to teach finance using data science and programming, to basically put it all together, to connect academia and a business. So, for example, I'm trying to find a good ways and legal ways to introduce teaching by companies in the program, and I did one course for that because we don't have any teachers yet who are specialized officially, formally, in terms of PhD in blockchain. And I wanted to have a course in blockchain and decentralized finance, and so we made an excellent arrangement with a great company, MVP Workshop, which is a specialist in that. And so we have somehow figured out a way in which we can incorporate them in our formal education, which is now the first course of this type. But I think this is much more that can be done in cooperation between companies and these formal programs, which can give us a lot more practical exposure. So also, as I said, since all of the teachers are also practitioners, when they teach, they are actually focused on things that are making sense from the practical point of view. Plus, we have the board that is overseeing this, and a board of people with like 20 plus experience in the field. Yes. It's just saying, okay, well, this makes sense. This is now obsolete and so on.
Okay, this sounds like you point out this is the last question from myself from Goran. From the practical point of view, what do you think are the most important challenges facing the body of data science?
Well, getting to know and understanding the realities of life, right? So it always makes me, yes, that's for every young professional. It always reminds me of that the famous scientific joke in Serbia about an entrepreneur asking for a team of engineers and scientists to how to optimize wheel production, right? Where finally it turns out that it can be optimized when a mathematician walks the room and starts explaining, okay, so I found the solution. Listen, if we assume that the cows is ideally spherical, right? So of course the problem is that cows are not ideally spherical, still you have to optimize production. So, I remember being faced with projects for which I would say, if I face them in an academic environment, I would say, well, just a decent research base for this would take 6 months. Just the question of methodology selection, to find, to work with data and finally realize, okay, are we going with a generalized linear model here? Are we going for random forests? Are we going for XGBoost? Are we going for something else? So we're simply giving up. Does it work? Okay. And but when you're really in the market arena, it will more often than not be a fact that you don't have 6 months for research phases and things like that. You have to deliver something in a month. You can study the problem for 2 or 4 days. And that is important for them to understand that part. Sometimes the crucial factor in that equation that you learn with the Blackboard will not be present in the data set. Well, how do we model that? What do we do in such cases? Sometimes you will see exactly the path towards a solution, but you have a huge data set and you have, 32 gigabytes of RAM at your disposal and, 6 physical and logical cores, and you still have to do it, right? So I don't know, maybe in the beginning that can look ugly to people, especially if they come from science and engineering and they invested a lot of that work and discovery. But very soon that also becomes fun, solving those kinds of things. So I think that's that, simply facing the realities of life. That's the most important thing is that.
So I just wanted to reiterate one point that you made. When I joined McKinsey, which was right after my PhD in theoretical physics, of course, I knew nothing about business. So they took us for a month to Switzerland, gave us INSEAD training in some mini MBA. And then they said, okay, now you're on the study. And the study was about credit card industry. And we were meeting 2 days from now basically the chairman of the American Express, and he wanted to hear our opinions on strategy going forward. And of course, I didn't know anything. I knew what is a credit card. I didn't own one. I was too poor most of my life to have a credit card. And then they told me, okay, you have 1 day to get familiar with what is a credit card. So they gave me about, I don't know, 1,000 or 2,000 papers. Yeah, of course, sheets of paper to read. They have a big library.
You can do it. After all, it was a PhD.
And then, you know, didn't sleep. And the next day I was ready to talk. Of course, I was not eager to be asked anything, but at least I could have an idea about what we can do. So, and then you do the best you can.
Okay, think about one book to propose to our listeners, just one sentence, and I would like to ask you to recommend one song or one art exhibit they should see.
One song or art exhibit?
Whatever you think first, what comes to mind.
I'm not sure about the art exhibits. That you mean something which is now running in Belgrade, in Serbia, or
what
in
has,
general?
In general, what has come to your mind as?
Well, the last thing, I mean, I returned from Berlin only 2 weeks ago, okay, and there's a fantastic exhibition of Donatello in the Grimaldi Gallery at Culture Forum. It doesn't have to do much with data science, I have to say. It's not algorithmic paper, etc. But the last one that really fascinated me was that one. Yeah.
Okay.
But why did I get the book question? Why did Blanco get the book question?
Because that's your.
Well, my case, I think, Fooled by Randomness by Nassim Taleb. I really like that.
I really like that one.
That's
I read that one for the first time during my PhD studies in New York, but I liked the Black Swan even better.
Okay. With this was the final question. We are a little bit behind schedule. Sorry for that, but with these two excellent people, that's all the time. Like it's fun to have to be a little bit after the what we have read. So thank you all. We do have time for questions, but if you have any questions, we are going to answer you via our social networks. Okay. Thank you so much and change on today.
Thank you for inviting us.
Bye-bye.
Ciao.